This is problem 60 of Neetcode 150, serialize and deserialize a binary 3. Alright, so we have to implement an algorithm to serialize and deserialize a binary 3. Serialization is the process of converting an in-memory structure in a sequence of bytes that it can be stored or sent across networks to be reconstructed later in another computer environment. Alright, so this is quite complicated and it makes the problem look much harder than it really is. So basically what we have to do, we have to convert this into first a string and then take that string and build back a binary 3 using that string. Okay, so first what we are basically gonna do is that we're gonna proceed with the pre-order tree traversal. So initially we are gonna go see the first node, and our logic here is that we always want to see if there's a left node. Okay, so we are just gonna take a look at one. Okay, so we are gonna put one in our string here. So this is our string, it starts with one. Or let's actually create first an array, and then we'll join them back with a comma. So we know that the comma is the separator between all the nodes. Okay, so after our one, we go to the left and we see that we have a two. So we are gonna put that two here, and then we can see that the left value again is null, right? So I put an n instead of none, but it really means none. All right, so then after this, we go back to our two, and we visit the right branch, and we see that the right child actually is none as well. So we're gonna put an n. All right, and now this is the time where we go back to three. So we are gonna visit three, and we are gonna add three in the serialized tree, right? So after this, we are gonna go again with our logic of going to the left. So we're gonna put 6 in it. And in 6, we are going to go again on the left, and we notice that we have none on the left. Okay, so what we're going to do once we reach that none, we're just going to go back 1. So we are going to go back to 6 and see what is up on the right side. And we also have a non value, so we're going to add n as well. And after this, we are ready to actually go back to our or 4. So we are gonna go see this 4, and we're gonna add this in the serialized array. And after this, we are gonna go to the left again. So we're gonna go see our 3. And guess what? After the 3, we are gonna go to the left again, see that we have none, right? And then we go back to the 3, go to the right, and see that we have none. And then after both left and right child are none, we can go back to 4, see what is up on the right, and we have another none. All right, so by doing so, we did a pre-order traversal, and this is exactly the logic we're going to use for the serialized function within this problem. This is 50% of the problem. The other 50% is about deserializing. So once we have this encoded message, how do we actually build up the tree? Well, actually, we are going to start with the one here. So we're going to take that one and we are going to add it there. And our logic is that the first value is always the value to the left, right? So if we have a value like 2, we're going to add it to the left, right? And now after this, we have another value, but it is none. So we're going to add this to the left. But since we have a none here, we are actually going to go back to 2 and go add the other value to the right. And the other value to the right is going to be none. Okay, and now since we have 2 nones, well, this is our signal to climb back to this 1 where we have our right side still undefined. So we're going to go see the right side, and the right side is initially going to be set to 3. And then on 3, we're going to go see the left side again, because it's always the left side that we see first. And we notice that we have a 6, right? And since 6 is a value, it's not a none. We're going to keep going on the left side again. But now we have a none. So this is where we break the left check, or the left side check cycle. We go back to 6. So we go back up by 1, and then we check to the right, see if there's something. And there's actually an n next in the list. So we're going to go back by 1 and by 2, and then we're going to go see the 3. And the next value here is, oh, okay. is actually going to be 4. So we are going to add 4 here, and then we can see that to the basically after 4 we have a 3, so the left value of 4 is 3, and both values are then non, right? So you have an n1 and an n here, and then you're going to climb back to 4, and you're going to have another non. Okay, so this is the logic that we're going to use to solve the problem. Let's try to actually code that up. So first, what I'm going to do, we have to return a string, but we also have to in our decoded message, in our encoded message, pardon me, we have to actually find a way to add a sort of a value between, like, let's say you have a node with value 1 and you have a node with value 2. You can't just put in the string 1 and 2. It will look like 12, and you will be unsure whether it is 1 or 2 or 12. So you need to have a value or a character that separates these. So actually, it can be whatever you decide it to be, but let's first create an array, put everything in the array, and then after this, at the end, just join all the characters in the array with our delimitator. So we are gonna set this to, let's say, the result, and the result is gonna be that array. And then we are gonna have to create a recursive function. So let's call this DFS, as we are using a depth first search function, and we're gonna pass the node into it. Now the first thing that we have to handle is the case where we have a non-value, right? So if we have a node that is none, so we are gonna append to our result. Let's just call this non, right? So we're gonna append the string non, okay? And also we are gonna return. So we're gonna call back our recursive calls as we reach the bottom of the tree. After this, before we call our recursive calls, we are gonna append to the res, or the results array, the value that we have, and we are gonna have to make sure that this value is stored as a string. So right, so just like this, and then we are ready to call our depth first search function on the node at the left and also the right child. So let's go ahead and do this, so that now for every single child, we're gonna go again in the depth first search function, and we are either gonna append non, returning the call if we have a non, or otherwise we are gonna add this value to the res. So we are gonna have a beautiful res array with all the values, or all the nodes values stored in it. With that being said, we have to then call the function starting at the root, and we have to basically return a string. So what we are going to do is that we are going to return something, right? And we're going to join all the values in the res. And actually, we just have to use a special character. Feel free to choose whatever you want to use. I will use a slash because this is going to be our signal that we then have a new value or a new node to create in our Deserialize function. And I think that this is it. Yes, so we created the Serialize function, and now we are ready to move to the Deserialize. All right, so in Deserialize, we are going to be given a string. So for good practice, we are actually going to turn that string back into an array so we can more easily manipulate it. So let's call this vals and make sure that we are gonna create or that we are gonna split that string that we're given. Oh, pardon me. So we're gonna split that string that we are given exactly where we have slashes. So this is where we set the limitation between the the node's value. So after this, we can create our depth first search function, because we're going to need a recursive calls on this as well. And actually, before this, I will create a value or a global value called I, and I will set that value equal to 0 at first, right? So the I is basically going to be the index. So we're going to start at the first index, and we're going to see if if on the array valve at the first index, right, which is going to be the index 0 on the first round, if this is equal to none, as we stored none for the actual non values or the non nodes, what we're going to do is that we're basically going to return none in the process of creating our new 3, and we're also going to move the I by 1, so we go see the next value. And also there's a thing I forgot to do, is that we are creating a global variable, so we have to ensure that Python is not going to create a local variable every time for I. So we are just going to say non-local I, and it will do the trick for us. With that being said, we can jump to the creation of a tree in the case where we actually have a value and we don't have a non. So what we're going to do is that we're going to set our node to basically a tree node. This is what we are willing to build. And the tree node is going to take basically the value at that index I, but we have to ensure that this value is turned from a string to an integer. So vals.I, there you go. That's how we build this, and after this we have to increment I by 1, and then we can basically use the recursion calls to create our node dot left and our node dot right. Okay, and we are just going to call the depth first search recursion like this. All right, and after this, on each round we are going to return the node just like this. And what to conclude the problem, we can simply return the call of that first search function, and this should be everything we need to solve this problem. So let's test that out, and there you go. Awesome. All right, so I hope you learned from this video, and I hope to see you in the next one.